Welcome to our discussion of Chapter 2. Chapter 2 is concerned with psychological research, and it's also known as research methods. So for those of you who have not been experienced with research, scientific research or something, a lot of the information in this chapter will be pretty new. So I highly recommend, you take your time through this process. Pause the video when you need to, take notes, and become familiar with the concepts and information. So let's proceed. So first of all, I'm just going to give you a couple of examples of, maybe questions that a researcher might ask. Like take, for instance, a researcher might ask, how does television content impact children's behavior? So that is an example of one type of question that a researcher might be concerned with. Also just wanted to show you that, back in early days, some of our ancestors, they believed that trephination, which was the practice of making a hole in the skull, allowed evil spirits to leave the body, thus curing mental illness and other disorders. So just, think about that. Is that very scientific? Does that, is anything measured? Is anything recorded? It's just something to think about. Just want to make you aware of, some of the development of, I guess you could say, some of the methods that researchers used or did not use. Okay, so research, uses definitely a combination of inductive and deductive reasoning. So inductive is basically the process of beginning with, one general thing, like a hypothesis, and then from that, actually reasoning to empirical observations, and then possibly to, from there, deductive reasoning, etc., etc. Now, the thing is I don't wish you to memorize this as much as just become kind of familiar with this, because we will elaborate as we go further. Okay? All right. So what's important is to know, you remember the formal definition of psychology is the scientific study of mental processes and behavior. Well, remember, scientific means that it uses the scientific method. And that includes, proposing a hypothesis. A hypothesis is basically maybe a broad, kind of like what you propose, what a researcher proposes is going to happen if they conduct research. So that's just a very simple definition. I just want to, make you generally familiar with that. We will proceed and elaborate as we go. But so definitely, hypothesis, that can lead to, then from there, once hypothesis is made, then you design a study and test the hypothesis, using research. So an example might be, let's just say a hypothesis was made and a researcher said basically that increased caffeine will result in decreased sleep. So then, how does the researcher proceed from there? Well, we'll design a study and test that hypothesis. So during that time, during that research right there, that's what the researcher will actually start giving certain people that are involved in the research, more caffeine, and then measuring their sleep to see if indeed, increased caffeine resulted in decreased sleep. Keep in mind, this is just one general example, okay? I'm trying to be simple, okay? And not make things too difficult right off the bat. So then, as the researcher is performing the research, then afterwards, remember I said, that, well, he or she will observe, whether indeed, the increased caffeine resulted in decreased sleep in participants. And then after that, as the researcher has gathered the data and everything, then he or she may come up with a theory. And so this is kind of a circular type process, but it's also a very simplified process. But I just wanted you to, use this as to kind of introduce you to this process. So let's come up with some definitions here. So first of all, what is the scientific method? Well, that is actually a set of assumptions, attitudes, and procedures that guide researchers in creating questions to investigate, in generating evidence, and in drawing conclusions. So that should sound pretty familiar at this point. This is what the process that I delineated in the previous part of the discussion. So let's move forward. So here are the steps of the scientific method. So step 1, right here. So formulate a specific question that can be tested. So I use the example like, will increased caffeine result in decreased amounts of sleep? And so that right there is a specific question. And then so the researcher will form a hypothesis, and that's a tentative statement about the relationship between two or more variables. So the variables in this question are caffeine and sleep, because those will change. So increased caffeine, that's a variable that changes. And then sleep, it can be more or less, and that is another variable that changes. That's why they're called variables. They don't remain the same value all the time. They actually vary according to what's done. And and then step 2 right here is the researcher will design a study and collect the data as the researcher proceeds. So take, for instance, just using our simple example, caffeine and sleep. Well, the researcher might say, okay, this part of the group, they will receive 100 milligrams of caffeine per day. And then this part of the group will receive, 300 milligrams of caffeine. This, and et cetera, 500 milligrams, 1,000 milligrams, and then measure each of their sleeps. Well, that's right there that's the steps involved in designing that study. And then, of course, the researcher will measure how much sleep each participant got. And that is called the data, the relevant data. Okay? And so let's just move forward. We don't have to memorize all this quite yet. Okay, step 3, after the researcher has collected the data, is the researcher has to analyze the data and come to conclusions. So using our example, once again, the researcher will say, definitely the data shows that as caffeine is increased in an individual, they experience decreased hours of sleep or time slept well or something. Okay, then step 4 is the researcher will report the results. So that right there, the step of reporting the results, that basically right there, here's a bunch of things. I'm not going to read each of these, but definitely, pause the video, take a look at these. But this is the kind of results that are reported in journals, in scientific and psychological journals, and written up into articles, and then those get published by the journals. Okay, and those are the steps of the scientific method. So on this frame right here, I highly recommend that you definitely pause the video and take very good notes on this. These right here are the scientific terms that you will have to be fairly familiar with. Okay, especially, a hypothesis, a variable. The operational definition, that just means how the variables in a study will be manipulated or measured. So take, for instance, using our example, caffeine and the effects on sleep. Well, how much caffeine and how much sleep each individual got, and those will actually result in what's called the operational definition. So that is basically how the design was studied. That's all there is to that. That's a simple way to think of it. Now, usually statistics refer to the type of math that is used by researchers to organize, summarize, and interpret their data or their data, however you want to pronounce that. I say data, but either is fine. Okay. Now, statistically significant, that's just another, it's another math figure, a mathematical indication that tells, how likely the results may have occurred by chance or may have not occurred by chance. So the more statistically significant results were, then the less likely that they would have occurred by chance. And so you'll hear researchers say that quite often. They'll say, well, I found this to be very significant or statistically significant, which means that's good news. Okay. A meta-analysis, all that means is taking the data, all the results, data results from a multitude of studies, many research studies, as is written right here, on one topic, putting all that data together, all of the statistics together, and coming up with one big statistic. So that is called meta-analysis. Now, last but not least is the term replicate. Replicate means basically to repeat or duplicate a study exactly in order to increase confidence in the validity of the findings. So what's really important is that most studies, especially in science, studies usually have to be what's called replicated. And that means by a variety of researchers and a variety of participants, probably through, if not the country, throughout the world, in order to measure and see how close results were for each researcher to the original findings. So that's what's called replicate or replication. So let's move forward and clear your head there a little bit. So here's a couple more terms here. So theory. So a theory is an explanation, a tentative explanation that tries to integrate and account for the relationship of various findings. Now you see right there, I put this right here in this type of font because various findings and observations. So I will give you an example that has nothing to do with psychology so much, but this is something that most of us has heard of, and that is the Big Bang Theory. Okay, so the Big Bang Theory is actually the result of many findings in many disciplines. So like take, for instance, definitely, all the different facets of science, all kinds of things. So I hope that makes sense to you. I'm not going to elaborate too much more on that. So let's move forward here. So pseudoscience, what is pseudoscience? So a pseudoscience, that is usually a theory, method, or practice that promotes claims, and even though they're not supported by empirical evidence, is lacking or non-existent. So pseudo basically means false or fake. So that's the kind of theories that are, proposed, but they're not based on science. And those can be found, especially, on a lot of social media these days and things like that. People are making claims about certain things that they believe in or, heard on social media, but they're actually not real scientific claims. So I just put here, can you think of some examples of pseudoscience? Might be something, you might want to put in our discussions, our chapter discussions or something. All right. Okay. So another type of research method is called naturalistic observation. Okay. So naturalistic, that just means watching people or animals in their natural habitats. So detecting, they look at the behavior of people in their natural habitat without stepping in and actually doing an experiment. So a good example is, like, say a researcher is studying violence, but more specifically, maybe violence at sporting events, and even more specifically, maybe not so much the athletes, but the people watching the games or something. So they may actually just go and observe and record behavior and collect data that way, and that's called naturalistic observation. That's just one example, though, so just want you to keep that in mind. So, I put an example here too. Those of you who know who Jane Goodall is, made a career of doing naturalistic observations of chimpanzees. So that's another good example. She would just sit, and observe and record and get to know, the behaviors of chimpanzees. But she would do it in a naturalistic way. She wouldn't interfere. She would just stay out of the scene and just observe. Okay. All right. Another term to be familiar with is what's known as a case study. So this is very, very simple. All a case study is, it's a description, a highly detailed description of a single individual. That means one person. And so a case study can be, I put in some notes here, so definitely read these on your own, but can be useful in clinical, neurological, and neuroscientific areas. Take, for instance, if a person is having issues and a neuroscientist wants to conduct a brain scan, such as an MRI or something, that right there is a specific study only on that one individual. So that is a case study. Now, a survey, most of you probably are familiar with what a survey is and may have even participated in some. Basically asking people their opinions, maybe behaviors, that sort of thing. I definitely pause the video here and look at this a little quicker. But I give you an example of a survey. Here's an example. Like, take, for instance, your opinion is important to us, and would you like to participate? And then you can click yes or no, etc., etc. And then that way you're telling these people your opinions and behaviors, according to the questions and what you feel comfortable answering. So that's an example of a survey. Now, another type of research is archival research. Right here, I put that in red. That's basically just examining records, whether they're hard copy or whether they're electronic records. So that's another form of research, believe it or not. Now, another term here is what's known as longitudinal research. That is this term right here in red, longitudinal. That means basically over a period of time. So researchers might want to understand, like, what are the effects of smoking? Well, they can't just conduct research and only check with a person one time and say, well, our data that we covered, was only on this specific date and this kind of this amount of persons. So what they will do is over a long period of time, they may, using longitudinal research, I'll use that term again, to help that kind of hammer that into your minds here. But an example might be following and collecting data with a group of persons, that are involved in the research, maybe over 10 years or 20 years, and measuring their health and how it changes while they smoke, that kind of thing. So that's just an example there. Now, often correlation, right here, correlation is this term, and that basically is concerned more with how strongly related two factors are to each other. So take, for instance, I'm just going to make up a really funny, strange correlation. But researchers might say, look, foot size has been shown to correlate with IQ measurement. So then they'll say people with bigger feet, have been shown to correlate with higher levels of intelligence or something. Now, of course, that's not true, but I'm just making that up, off the top of my head just to be kind of funny or whatever. But basically, they're not saying that correlation. Let me rephrase that. Correlation is not concerned with saying that something causes something else. They're not going to say, big feet cause higher intelligence, but they may say, but our research has shown that larger feet, are correlated with higher IQ scores or something of that nature. But they are not saying that it causes it. They're just saying that those two factors are correlated to each other. Okay? And then usually correlation, that also is usually shown in a number. And believe it or not, usually that number is just between, like, say, -1 to +1. And that right there, the closer it is to 1 or -1, then the stronger the correlation is. And then if it's 0 right in the middle, then that means there's no correlation at all. So a positive correlation is right here. And please pause the video here and take notes and make yourself familiar with this, if you need to. But a positive correlation is a finding that two factors vary in the same direction, increasing or decreasing together. Okay, I'm going to give you an example. Positive correlation. Well, like, take for instance, say a study is concerned with hours of study per day and GPA. Well, so both of those usually will, the study might say that they are positively correlated because the more studying per day, the higher the GPA. So they both went up in the same direction. Okay. Now negatively correlated or negative correlation is a finding that two factors can be in opposite directions. So one increases as the other decreases. So a great example is the one I used earlier, where like say an increase of caffeine will result in a decrease in good sleep. So that can be a negative correlation. Now right here, I just want to show you that I included some charts. These are little data points right here. These are called scatter plots, by the way. So all they are is dots of data points. So you can see right here, this says positive correlation, and those are both going in the same direction. See, as weight and height both increase together. Okay. Now the thing is here's a negative, a negative correlation right here. And you can see right here as hours of sleep go up, right here. So there's tiredness right here, right? But did you notice though, these are going in different directions. So definitely hours of sleep, this is really high. There's no tiredness whatsoever over here. But did you notice that as hours of sleep are starting to go down, tiredness is starting to increase? And so that's what's called a negative correlation. They're moving in the opposite directions. And then last but not least, shoe size and hours of sleep. Here's another funny example, but there's no correlation whatsoever. As you can see, this is just this scatter plot right here. These dots are just all going in all kinds of directions. There's really no direction whatsoever. It's just varied. So that's just something to be aware of, and it's very important to know for this chapter. Okay, now we're on to what most people, when they think of a type of research, they think of experimental research. And so you remember earlier when I said correlation, that's not concerned with cause and effect, but experimental research is concerned with cause and effect. The researchers want to know, if I change this in this variable, does that cause this change in this other variable? And that is the cause and effect relationship between the two variables. So definitely involves deliberately varying one factor, which is called the independent variable. So a good example will be, that is the variable that's purposefully or definitely consciously manipulated in order to see if something changes with the other variable, and which is called the dependent variable. Now, students usually are kind of a little bit confused about this. So this is the way I think of it and the way I memorized it when I was a student. The dependent variable, hence right here, here's the important thing. It uses the word depend. So its status depends on what you do to the independent variable. Okay? And so that is just something very important to understand. So remember, deliberately varying this factor right here, the consciously doing that is the independent variable, and then the dependent variable might experience some changes. Okay, let's move on. Now also, more often than not, in an experimental research, there will be a control group. So the control group usually receives a placebo, and a placebo can be anything from like basically one of these pills right here, and it might not contain anything except maybe sugar or something. But believe it or not, people's expectations when they're going into an experiment or something, they can actually experience some kind of changes in their thinking or their physiology or their behavior purely because they expect to, but it's really not the result of medications. So I'm going to give you an example here. Take, for instance, researchers concerned with measuring the effects of a new antidepressant. And so the researcher will give one group the antidepressant, and then we'll give another group a placebo, and then measure the effects for each one, and then compare those to each other. And so usually the researcher might say, well, my data shows that giving this antidepressant definitely reduced the instance of depression in these participants. And whereas the people who received a placebo, maybe 20% said, yeah, I'm definitely feeling better now. That medication really helped me. Well, when they were actually just receiving the placebo, which could have been just a sugar pill or some kind of starch or something. So that's what a placebo is used for in experimental research. Okay, now a couple of terms to be familiar with too are these terms right here that I put in red. So a large population refers to the entire group, an entire population. Like take for instance, if a researcher wanted to measure the effects of 1 hour of study per day, 5 days a week, with all students at Red Rocks Community College or whichever college you happen to go to, well, the entire population would be all students at that college. Okay. Now the only thing is though is it's really hard to get every single student in a college to participate in a research experiment. So the researcher will more than likely get a sample group. That's the second term right here in red. And so that's a smaller group of people that represent the entire population. So the researcher might want to get an even number of students from each grade level, and both males, females, etc., any sexual identity. And that way the sample group actually represents more closely the entire population for the college. So I hope that makes sense to you. Let's move on. Okay, so basically when a researcher wants to conduct research, especially research that involves human participants, they have to submit their research intentions to an institutional review board. And usually we psychologists or scientists, we just say IRB for short, which stands for Institutional Review Board. And so when I was a graduate student, I did do research with students from various colleges in order to study the results of certain teaching methods. And all of my research had to be okayed and had to be reviewed by an IRB. So just know that, so a researcher just can't say, oh, I'm just going to measure this and I'm going to get some people to get involved and to be participants. They actually it has to be reviewed to see if it's ethical and it contributes to scientific knowledge. So that's what the IRB does. Remember, IRB stands for Institutional Review Board. I realize I've said that a few times, but I'm all about repetition. Okay, so last but not least, we're just going to talk about some ethics. So ethics means rules, guidelines that guide behavior of researchers. So that that way it ensures that they don't do any harm, and that they're doing the right thing. They're not doing anything wrong that's that's not scientific or not kosher, according to the American Psychological Association. So here was an example of way back in in the 1950s, of a research where a researcher was acting like he was getting or actually hired somebody who acted like he was getting shocked. And so that is not ethical now. I'm not going to go too much into this, but if you feel like you want to review this, I definitely put the details. That's the Milgram experiment in the early 1960s. I think I said 50s earlier, but it's the early 1960s. So this is now unethical. Psychologists, scientists, and everything, they're not allowed to, cause physical, psychological harm purposefully, to participants. So, those are just some ethics, that's not all of them, but those ethics are guided by the American Psychological Association, which is known as the APA for short. So here's an example of another, I was just trying to give you a couple of examples here. So this is definitely not ethical anymore, but in this Tuskegee syphilis study, scientists actually gave these participants an injection of syphilis, and in order to measure the effects, so they purposefully allowed these participants to be harmed. Well, that is not ethical any longer. And so I just wanted to give you another example, because I think that the more we talk about that, and more examples we take a look at, you will have further insight into this. So last but not least, there's a few things, that researchers are required to do. They give an informed consent. So basically informed consent just tells the participant what we're going to do in this study. And, and then if the person agrees to participate in the study, then they sign the informed consent. And that is voluntary participation. They're not allowed to be forced into participating any longer. Okay. Definitely, there are guidelines using students as research participants. The use of deception, that can be deceptive. And I say that kind of, tongue in cheek, but it is, true. We are allowed to use a little bit of deception, but only if we tell afterward that we did it, and it's for, if it results in a scientific type, it's for scientific reason. So often, participants are very, savvy, and they may quickly say, "Oh, I see what this study is about." And so they'll change their behavior to meet the needs of the study. Well, researchers, in answer to that, they will often maybe use a little bit of deception. So participants can't adequately tell what a study is about. That's just an example. Now, confidentiality of information, that means all information about participants and what they went through and who they are and what they did, that's all confidential. And files are definitely kept in a safe place, and if files are kept, and it's all confidential. Okay, and last but not least, at the end of the research, researchers are required to give information about the study and debrief. And debrief means just telling the participants, look, here's what we did in the study, and here's how we did it. That's called debriefing. So that concludes our discussion. I realize there's a lot of information on this video and in this chapter. So a couple of things. Watch this video again when you have time. Stop and take notes when you need to. Read this chapter, and then of course participate in discussions, and that should help you a lot. And we will see you in a discussion for the next chapter. Good luck.